Good day everyone. So this day I will be going to discuss the assignment problem. So in this ebook, we have a assignment problem that can be solved by exhaustive search. So there are n people who need to be assigned to execute n jobs, one person per job. That is, each person is assigned to exactly one job and each job is assigned to exactly one person. The cost that would accrue if the ith person is assigned to the jth job is a known quantity, is the cost, I and j, which is the I here is the person and j here is the job. For each pair, I, j is equal to 1, 2, and so on, and the problem is to find an assignment with the minimum total cost. So here in assignment problem, all we have to find is the minimum total cost. So we have here a given cost matrix. We have 4 persons and we have 4 jobs. We have also here some iterations for solving the cost matrix. Here is the cost matrix. Here is the jobs. And here is the cost. So let us solve it in the next page. So here, we have a cost matrix here, and we have also here the jobs and the cost. So in order to get the minimal cost of an assignment problem, all you have to do first is to identify what is the I and what is the j. So I and what is the j. So the I here is the person and the j here is what is so called is the job. So first we have to put here a I, which is the person. So in person, so we have 1, 2, 3, and 4 person here, and we have also 4 jobs here. Okay, so we were going to have an exhaustive search. So in person 1 is assigned to job 1, person 2 is assigned to job 2, person 3 is assigned to job 3, and person 4 is assigned to job 4. So let's go here in the graph. So person 1 is assigned to job 1, so which is 9. So let us type here the cost, 9. Person 2 is assigned to job 2. Here is the 2 assigned to job 2, so this is 4. So let us here write 4. And person 3 is assigned to job 3. So where's the person 3 is assigned to job 3, so this is 1, so let us write here 1. And person 4 is assigned to job 4. Person 4 is assigned to job 4, so which is 4, so let us write here 4. So in cost, 9 plus 4 plus 1 plus 4 is equal to 18. Okay, so let's try 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3, 1, 4, 3, 2 will have its cost. Okay, so here are the costs. Then in an exhaustive search, you have to do some possibilities to get a minimal cost. So you have to also to write here a, like for example, 2, 1, 3, 4 is the cost. So let us check. Person 1 is assigned to job 2, so that is 2. Person 2 is assigned to job 1, so which is 6. Person 3 is assigned to job 3, so that is 1. Okay, then person 4 is assigned to job 4. So person 4 is assigned to job 4, so which is 4. So the cost here is 2 plus 6 plus 1 plus 4. It will go to 13. You can also have a 2, 1, 4, 3, 2, 4, 1, 3, and so on, and etc. Okay, so that is an exhaustive search. So, medyo nakakapagod po kasi lahat po ng mga possibilities ay kailangan mong gawin para makuha yung minimal cost. But so, there is another way or an easy way which is called the Hungarian method. So, let's find out what is Hungarian method. So, in Hungarian method, we have two types of assignment problem here. First is the balanced assignment problem, and the second one is unbalanced assignment problem. Balanced assignment problem, it is what we call the number of rows is equal to the number of columns. So like for example here in the table or in the cost matrix, we have 4 person here, 4 row, 1, 2, 3, and 4, and 4 columns rather. Okay, so that is a balanced assignment problem. Then what is unbalanced assignment problem? So it is the number of rows is not equal to the number of columns. Okay, so let's find out. So what is unbalanced problem? If there are 4 rows but there are 3 columns, so that is unbalanced assignment problem. Okay, so next, there are steps in Hungarian method. So first, you have to subtract the minimum value of each row from the entries of that row. All you have to do is, in step number 1, you have to find the row minimum. And number 2, subtract the minimum value of each column from the entities of that column. All you have to do is find the column minimum in step number 2. So let us solve the problem in cost matrix. So first, we have to find the row minimum. Okay, so let's start. All we have to do here in row is to find the minimal number. So in each row, so we have 2, here we have 3, we have 1, and we have 4. Then we have to subtract each row to its minimal number. So 9 minus 2 is equal to 7. 2 minus 2 is equal to 0. 7 minus 2 is equal to 5. 8 minus 2 is equal to 6. 6 minus 3 is equal to 3. 4 minus 3 is equal to 1. 3 minus 3 is equal to 0. 7 minus 3 is equal to 4. 5 minus 1 is equal to 4. 8 minus 1 is equal to 7. 1 minus 1 is equal to 0. 8 minus 1 is equal to 7. 7 minus 4 is equal to 3. 6 minus 4 is equal to 2. 9 minus 4 is equal to 5. And 4 minus 4 is equal to 0. So that is the row minimum. Okay. So next, step number 2 is to find the column minimum. All we have to do is copy this row minimum in the second table. Okay, so let's copy it first. Okay, then we have to write here a column minimum, or find the column minimum here. So this is the column here. Okay, so let us find the minimal number. So we have here 3, we have here 0, we have here 0 also, and 0 also. Okay, next, subtract this column to its minimal number. 7 minus 3 is equal to 4. 3 minus 3 is equal to 0. 4 minus 3 is equal to 1. 3 minus 3 is equal to 0. Next column, 0 minus 0. And all number with this subtracted to 0 will be the same result. Okay, so let us copy this. 0, 1, 7, 2. Next, because it will be subtracted to 0, then let us copy this also. 5005, and copy this. 6, 4, 7, and 0. So we have now a column minimum. Next step is the row scanning. So all we have to do here is copy this table into the next table. So let's copy it first. Okay, so our third step is the row scanning. So in row scanning, starting from the first row, here, the first row, ask the following question. Is there any exactly 1 0 in that row? If yes, mark a square around that 0 and draw a vertical line passing through that 0, otherwise skip that row. Okay, so let us try this. In row scanning, in this row we have 1 0, so let us mark here a square and draw a vertical line. In second row, we have 2 zeros, so we have to skip that. In third row, we have 1 0, so we have to mark it square and draw a vertical line. In row number 4, we have 2, 0, then skip that for now. So that is, we have now a row scanning result. And then next, the last step here is what we call the column scanning. Okay, all we have to do here is copy the result in row scanning into the column table. So let's copy here the result of the row scanning. So the only difference here in row scanning and column scanning, the row scanning, we have to draw a vertical line, but in column scanning, you have to find a zero in column and draw a horizontal line. So let's try this one. In column number 1, we have 2 zeros, so we have to skip that for now. In column number 2 and column number 3, so these are also deleted now, so we have nothing to do here. And in column number 4, we have 1 0, so we have to mark it square and draw a horizontal line. So, and that's all. So that is for column scanning. Okay, so let's write here the result. Okay, so if this column or if this table is feasible or optimal, because in assignment problem we have to create an optimal solution or feasible solution. So let us write these results. So in result, we have to check if the number of mark are equal to the number of rows. Okay, so we have 3 marks here, 1 2 3 square here, and equal to what? How many rows? 1 2 3 4. So we have 4 rows. So 3 is not equal to 4, then it is not feasible, and also this is not an optimal. So what are we going to do next? Because we have to create an optimal solution or feasible solution. Okay, in assignment problem, multiple selections is also exist in column scanning or in assignment problem. Okay, all we have to do here is find a 0 in each row and draw a vertical line. So let us find here. There are no 0 here. There are here in column or in row 2 there are 1 0. So let us write here a square or mark here a square and draw a vertical line. Let us check in row number 3. So we have no 0. Row number 4 is also deleted. Okay, so let us check the result. Now we have 1 2 3 4 rows of 4 squares, and also we have 1 2 3 4 rows. So is this a feasible solution or optimal solution now? So it is. So for the number of squares is equal now to the number of rows. So this solution is optimal or feasible. So let us get now the minimal cost here in assignment problem using Hungarian method. So let us write here the person 1, person 2, person 3, and person 4. Okay? All we have to do here is find the square in each row and each column. So in person 1 is assigned to job 2. Okay? Person 2 is assigned to job 1. Person 3 is assigned to job 3. And person 4 is assigned to job 4. Okay? So let us write here the cost. So let us check the table before. The person 1 is assigned to job 2. Person 1 is assigned to job 2. So that is 2. So let us write here 2. Person 2 is assigned to job 1. Then that is 6. Person 3 is assigned to job 3. So that is 1. Let us here write 1. And person 4 is assigned to job 4, and that is 4. Let us write here 4. So 2, 6 plus 1 plus 4 is equal to 13. So 13 is our optimal solution. So let us check here our recent solution using exhaustive search. So that is the solution before. You have created the possibilities to get a possible solution, and we get the cost here, and we get the solution here, which is 13. And also in Hungarian method, we have the cost, which is 13. So that is the optimal solution. And that is for my assignment problem.